Hi my friends, today we model this bevel gears which is placed in front of this silhouette to see how big it is. The interesting thing is that we can create rotation and the source for this gears is also from Timoteo Carrera Soto. This is his drawing. I emphasized the module, the number of teeth, and this dimension. He has also other drawings, but this is more for create drawings by hand. We use modern tools and means by using Inventor. This part is taken from Timoteo Carrera Soto drawings, and you can download it by watching the tutorial number 182. We start modeling by using this data, as I said. Module is 16, of course, for both wheels. The number of teeth is 36 for this one, 18 for this one. And we need to know this dimension. The rest of the data will be used after we create the generic parts. Knowing this, let's start. We can create a spur gear or a bevel gear. We have to create an assembly, standard millimeters IAM. Then we'll use the design and bevel gear, as you will see. But firstly, I want to place two axes here, which will be used as base for our construction. You don't see anything, so that I use Alt F5 in succession, as you know. Okay, now we see that two axes. We activate bevel gear. We have to save the assembly. Okay, we save the assembly. And now we have the generic data, so that we have to use this mentioned data. The module is 16. The number of teeth for the first wheel is 36. 18 is for the other wheel, and the face width is 125. A large bevel gear with the module 16. This is large, and this face width. That's all we need for the moment. Then we activate the axis, cylindrical face or axis. Okay, we save the created data and we have nothing. Now we have something here. This is what we have. It was very small dimensions here, because as I said, this is a large group of wheels. I go back to presentation, Alt Fi, presentation. Okay, and now I want you to know what we have. We have this element in the browser. What is this? This is the combination of the two wheels. We extend this and we see that this is bevel gear 1 and bevel gear 2. In Romanian this is pinion and this is coroana. In English, pinion and crown. It can be seen that the two wheels form a moving gear. Yes, I go back to the initial position because I want to show you what is here. This is the bevel gear number 1, which is the crown here, and you see two planes which I make visible. This one is very, very small, so that I select it and I apply auto resize. You see how it looks. Then I make the same thing to the other wheel with mesh plane and top plane visibility. Again, one is very small. This is that one, and I make it auto resize. When I rotate one wheel, the movement is visible, and we can see that the wheels are moving. In order to control these two wheels, because I want to create the other features to have this final model. To do this, I also make visible this plane, visibility, and now if we move this, we can see which one is fixed. This one is fixed. I apply constraint between this plane and this plane. Okay. I hide this all planes, visibility, both visibility and then the other wheel, visibility. Now, in order to modify the two wheels, we can enter on each one, double click. This is the bevel gears as an assembly, and now another double click to enter on this model space. We apply material steel carbon for this one. Go back to the assembly of two, yes, not all the assembly. Double click the other one and again steel carbon. Return and return. Okay. Now you know how to get access to each component. We want to apply this shape and dimensions of each wheel. Let's start with this one. We go to the first wheel, double click, and we are surpasses this step and this step. Yes, now we can edit this part. We open the origin, we select this face, and we create a sketch. I project this circle and this circle, and we have the two ending lines. F7. Now we apply all these dimensions by creating this contour all over. I make all these lines as construction lines. And I draw my own lines. I project this edge and also this edge. Then I draw lines. Start from here, create this, and then other lines. Horizontal, vertical, back to here, up, so, and to this line. The axis, let me see where is, here is. I think I must project this line to make it center line. Then I hide this so that I can place dimensions 85, (165). You see this is aligned with this. I project this line. I make parallel the two, these two, and I apply 30 here because we can see here this dimension. We can consider that this is also 30. Then other dimensions are an arbitrary 10 here. 5 is this. (18) here. I make them perpendicular, and this is very good. This is already parallel to this. Now I draw lines for using them as a shared contour, shared sketch. This is one. For this space, I draw a normal line here, and another line is placed, as you can see, extended to the left. Here is a lot of small entities, so that I apply coincidence between these two. We still have a dimension needed. Let me see if I find it. Where is it? Here. Oh yes, remove. I forgot to place this last dimension, which is 107. Finish sketch. Revolve. We start with external this, added about a known axis, plus I select something like this, and also this. These two are on the same axis with cut. Okay, you see, this is the new sharing sketch. Now we have everything we want. About revolution, then we apply this cut with dimensions 100, 120, and 200 with 290. Let's do this. Face, sketch, circle, 2 90 and another one 200. Then 2 lines, this one and its symmetric line. If I have an axis here, I don't have, I will project it. The axis is Z. I draw this axis, as you can see, between these two points. F7, trim. I make it to be coincident with this point. Now we have an axis to select, and I apply mirror. This line about this mirror. Okay. Dimensions are 100 between these 2 points and 120 between the other 2. Then I apply split here and here, and also here. Why? Because I make this construction finish sketch, and I apply extrude of this area with cut through all. I make 5 millimeters fillets inside here. Okay, and now I apply circular pattern for this 1, 2 objects, entities, features about this axis to be 4, not 6. Okay. Have the crown finished. Then we go to the pinion. Yes, return and double click here. We apply the same procedure here. Origin, mesh plane, project this circle as a line. Okay. Now I turn it as in the drawing, F7. All these must be, look how many, as a construction, because I draw two lines. One is this one, then I project this line and I draw other lines. This perpendicular on this. Now we know. We go inside, outside, and through. But there is a number of lines here. And back to this one. This is perpendicular to this, and we can apply dimensions. I draw an axis as a center line, then dimensions. This is 140 to this. And the drawing is 50 plus 90. Then 5 millimeters here. $30 if these two are parallel. I suppose they are. No, they were not. 30 is this dimension. A fillet of 5 between these two. A dimension here, this diameter of 125. Two dimensions needed. Let me see which dimensions. Oh yes, remove. We have to place here diameter of 120. I draw this line as I did before. I make it aligned with this line and I create another one up to here. We have external. No, this is external, this is external, and here 1, 2 internal. Let's apply them. If I don't catch all dimensions, is no problem. You can see what happens and you can correct them. Revolve this, and this is to be added about a known axis plus the internal, this one and this one with cut. Same axis. Okay, something is missing here, so that I double click and I select this tiny element area. Okay. Once again, plus, I have to apply plus for this small area. Oh, I have to apply plus, not cut. Okay, that's all. Return once again. You see we can rotate this, and we finished the model. That's all for today. Thanks for watching. Bye bye.